So 3 dogs are tugging on a toy. Argy is pulling at 80 pounds, Bobo at 60 pounds, and Chuck at 40 pounds, but all at different angles. Looking at this from above, we can see that Argy is pulling at an angle of 20 degrees from the minus x-axis, Bobo is pulling at 40 degrees to the positive x-axis, and Chuck is pulling at minus 40 degrees also to the positive x-axis. So the question is, what is the magnitude and direction of the net force on the toy? To figure that out, we're going to decompose each vector into its x and y components, add all the x components to get the x component of the resultant, add all the y components to get the y component of the resultant, and then combine those together with the Pythagorean theorem to get the resultant magnitude, and use a little trig to get the resultant angle. Ready? Let's do it. Starting with Argy, we can see that his angle is 20 degrees with the minus x-axis, which is the same thing as 160 degrees with the positive x-axis. We can use either of those numbers, but if you use 20 degrees, you're going to have to think about it and apply positive and negative signs where necessary. If you use 160 degrees, it'll come out naturally in the math. And as you're following along, don't forget to have your calculator in degrees, not radians. X is adjacent, so we use cosine, and 80 pounds cosine of 160 degrees is minus 75.2 pounds. Notice that 80 pounds times the cosine of 20 degrees is positive 75.2 pounds, but we know it's pointing backwards, so you've got to put in that negative sign if you decide to use that 20 degrees. The y component is opposite the angle, so 80 pounds sine 160, or 80 pounds sine of 20, is 27.4 pounds. Bobo's x component is 60 pounds cosine of 40 degrees, which equals 46.0 pounds. And Bobo's y component, opposite the angle, is 60 pounds sine of 40 degrees, which is 38.6 pounds. You'll notice that he's pulling a little more sideways than he is up, which makes perfect sense for an angle of 40 degrees. Similarly, Chuck's x component is 40 pounds cosine of minus 40 degrees. You could use 320 degrees here instead, and you'll get 30.6 pounds either way. His y component is 40 pounds sine minus 40 degrees, which is minus 25.7 pounds. Note that you could have just used 40 degrees and then forced the negative sign because you know it's toward the negative y. So now that we have all of the individual components of our vectors, we need to find the components of our resultant, which is extremely easy. Simply add up all of the x components of the vectors to get the exponent of the resultant. Add up all of the y components of the vectors to get the y component of the resultant. And there you go, those are two sides of a right triangle. Our resultant is minus 1.4 x hat plus 40.3 y hat pounds. Of course, that's clunky to say, and what we're usually interested in is the actual magnitude of the resultant, not of its components. So let's use the Pythagorean theorem, just a squared plus b squared equals c squared, and solve for c squared. And here you go. Rounded off, the resultant is 40.3 pounds. Now what direction is it in? Well, just looking at the components, it's almost all the way up and a little bit to the left. So we know it's going to be some tiny angle with the positive y-axis. We have x and y and the hypotenuse, so you can use arcsine, arccosine, or arctangent, whichever one you prefer. I'm going to use arctangent here, and here's our answer. Minus 2 degrees to the positive y-axis. Almost straight up, a tiny bit to the left. And there you have it. There's your final answer. Note that if this drawing were done properly to scale, rather than mocked up crudely in Microsoft Paint, you could have added the vectors head to tail and gotten the same answer. Neither method is intrinsically better than the other if done carefully, but mathematical calculation is less prone to error. So that's it. No matter whether you have 2 vectors or 3 or 27, split them up into their x and y components, add the x components separately, add the y components separately, and then combine them as a right triangle using the Pythagorean theorem and trigonometry.